Hello, this is Mrs. Westmoreland, and today we're going to talk about limiting and excess reactant problems in stoichiometry. So the main way that you are going to recognize that it is a limiting reactant problem is that you will be given two measurements in the question, and both of them will be about a reactant. And so ultimately you'll need to decide which one is going to determine how much product you can form. The substances only combine with each other in their stoichiometrically correct amounts, so one of the reactants will be completely used up, and that one's known as the limiting reactant, and there will be some of the excess reactant left over. There are actually several different equally logical ways of approaching these problems, but I'm going to show you the one that I've found to be the most student-friendly version, and this is listed as method 1 on your limiting reactant notes page that I am displaying right now, called method 1. So first, as always in stoichiometry, we have to have a balanced chemical equation, and so you will automatically know that it is a limiting reactant problem when you're given measurements of both reactants. So when you're given both reactants, you're actually going to do the dimensional analysis 2 times. So start with one of the numbers given in the problem about one of the reactants and work the problem to figure out how much product would be formed if you used up all of that reactant. And then you work the dimensional analysis a second time with the second number and the second reactant, solving for the same product. And then the idea there is if we used up all of that reactant, that would be how much product would be formed. And then we choose the answer that gives you the least amount of product, because the least amount of product will be the reactant that runs out first. So whichever one gives you the smallest answer is the limiting reactant, and whichever one is the larger answer will be the excess reactant. So let me show you an example problem off of the mass volume limiting percent worksheet. So this is number 5 off of that worksheet. So we have 5 grams of aluminum metal mixed with 6 grams of oxygen gas in a synthesis reaction. So the balanced chemical equation is above. So we have aluminum metal, which is an element, but not part of Brinkelhoff, so it's just written as Al. We have oxygen gas, which is part of Brinkelhoff, so it has to be written as O2. And then the product is the combination of those two in an ionic bond. So we have to balance out the charges. Aluminum 3+ combined with oxygen 2- gives us Al2O3. So once we have the correct formulas, then we need to add the coefficients to have the same number of each atom on both sides of the equation. So we want to know what is the maximum amount in grams of aluminum oxide that can be produced, and also what is the limiting reactant and what is the excess reactant. And really we can answer A and B sort of simultaneously. So I start one-dimensional analysis chart with my 5 grams of aluminum. And what I want to solve for is grams of aluminum oxide, which is my goal for letter A. So grams to moles using the molar mass of aluminum. Then I cross the mole ratio bridge using the ratio between aluminum and aluminum oxide. And then I go from moles of aluminum oxide to grams of aluminum oxide using the molar mass of aluminum oxide, the 102, which is 2 times the mass of aluminum plus 3 times the mass of oxygen from the periodic table. So when I do that stoichiometry and I calculate that answer, I get 9.44 grams of aluminum oxide. But I'm not finished yet. Because this is a limiting reactant problem, I must do the stoichiometry twice to prove that that is indeed the true amount of aluminum oxide that's formed. So I start a second dimensional analysis with my 6 grams of oxygen. solving again for what's asked for in letter A, the grams of aluminum oxide. So grams of oxygen to moles of oxygen using the molar mass of O2. Then we cross the mole ratio bridge, moles of oxygen to moles of aluminum oxide using the coefficients from the balanced chemical equation. And finally, moles of aluminum oxide to grams of aluminum oxide using the molar mass of aluminum oxide. And in that case, I get 12.8 grams of aluminum oxide. So I have to solve both. The idea is if I use up all 5 grams of aluminum, how many grams of aluminum oxide would I expect to have? 9.44. And if I used up all 6 grams of oxygen, how much aluminum oxide would I expect to have? 12.8. Well, the smaller answer is going to be the one that runs out first. So my true answer is 9.44 grams of aluminum oxide. And the reactant that got me that answer, the aluminum, is my limiting reactant. The other reactant, the oxygen, is my excess reactant. Now this question also asks for the mass of the excess reactant that's left over. And for this we're going to use the law of conservation of mass. This is really only possible because we only have one product in this equation. So our original masses of our reactants was 6 grams of aluminum and 6 grams of oxygen. And we formed 9.44 grams of aluminum oxide. Well, the law of conservation of mass tells us that the amount of reactants used has to be equal to the amount of product formed. So if we subtract the amount of product formed from the amount of reactants we originally had, the difference will be the mass of the oxygen left over, because we know that the limiting reactant is completely used up. And so whatever difference between our starting mass and our ending mass will be the amount of the oxygen that's left over. We'll do a lot more practice with this from the lab and in class, but thank you for watching.